Hello, in this lecture we'll find out the area of a circle. In the drawing we have quadrilateral ABCD. Inside this quadrilateral we have this circle. In addition, we know that side AB equals to 2 units in its length, side BC equals to 8 units, side DC also equals to 8 units in its length. This is angle ABC, this equals to 90 degrees in its size. This is angle DCB, this is also a right angle, this equals to 90 degrees. Again, our mission is to find out the area of this circle. So first of all, we will do construction. That is to say, we will extend side DA and side CB of this quadrilateral until they touch each other. So actually, this is their touching point. We'll define the touching point as M. We'll define this angle as theta. So, in the right big triangle DCM, this angle equals to theta. This angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees. At 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. Side CB or line segment CB is one side of quadrilateral ABCD, therefore it is absolutely a straight line. Then when we extended the straight line CB by straight line, the result is CM. Here the result is CM. When you extend the straight line by straight line, the result must be a straight line, therefore CM is a straight line. So if you focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is equal to 90 degrees plus the missing angle ABM. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle must be equal to 90 degrees. So, therefore, triangle ABM is a right triangle. So inside the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. So write it down. In the next step, we'll prove that the right big triangle, triangle CDM, is similar to the right small triangle, triangle MBA. So I write it down. We'll prove that the right big triangle, triangle CDM, is similar to the right small triangle, triangle MBA. So write those two right triangles are similar to each other. First of all, those two angles, they are both equal to 90 degrees, therefore they are equal to each other. So actually this is angle DCM. In the right big triangle, triangle CDM, and it is equal to this angle, it is actually angle ABM. In the right small triangle MBA. This is again angle DCM in the right big triangle CDM equals to angle ABM in the small right triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. That is a common angle. It belongs to both triangles. So we can write down that angle theta equals to itself is a common angle that belongs to both triangles. So if we relate to angle theta as it belongs to the right big triangle CDM, it will be defined as angle DMC. And it equals to itself. So if we relate to angle theta as it belongs to the right small triangle MBA, it will be defined as angle AMB. Repeat again. This equation means that angle theta equals to itself. We just called to angle theta two different names. Angle theta equals to itself as a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually this is angle MDC. In the right big triangle CDM, and it is equals to this angle that is actually angle MAB in the right small triangle MBA. Repeat again. Angle MDC in the right big triangle CDM equals to angle MAB in the right small triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles of the right big triangle CDM are correspondingly equal to all the three angles of the right small triangle MBA. Therefore, we actually proved that those two right angles are similar to each other according to angle similarity rule. So I write it down. We actually proved that the right big triangle CDM is similar. This is the sign of similar to the right small triangle MBA. According to angle similarity rule. And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that side DC of the big right triangle CDM over side AB of the small right triangle MBA equals to side CM of the big right triangle CDM over side BM of the right small triangle MBA. Repeat again. We will derive that DC over AB equals to CM over BM. DC equals to 8 units in length over AB. AB equals to 2 units in length and it is equals to CM. From the drawing it is very easy to see that CM in total equals to CB plus BM. That is to say CM equals to CB, that is 8, plus BM, that is the missing side. So in total CM equals to 8 plus BM. So in conclusion, found out that 8 over 2 equals to 8 plus BM over BM. 8 over 2 is 4, so 4 equals to 8 plus BM over BM. Here we multiply this equation by BM and we get that 4 times BM equals to 8 plus BM. Repeat again, 4 times BM equals to 8 plus BM. Here we'll subtract BM from this equation. And we'll get that 4 times BM minus BM is 3 times BM. That is equals to 8. Here we will divide this equation by 3. And finally we will get that BM equals to 8 over 3 units in its length. So here side BM or line segment BM this side BM equals to 8 over 3 units in its length. In the next step, we'll implement the Pythagoras theorem on the small right triangle, triangle MBA. Here by PT is the abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle MBA is AM, therefore the square of the hypotenuse is AM squared, and it must be equal to AB squared plus BM squared. Repeat again. According to the Pythagoras theorem, in the right small triangle MBA, AM squared equals to AB squared plus BM squared. So AM squared, that is the square of the hypotenuse, equals to AB squared. AB is 2, therefore AB squared is 2 squared, that is 4, plus BM squared. BM is 8 over 3, therefore BM squared is 8 over 3 squared, that is 64 over 9. So in conclusion, found out that AM squared equals to 4 plus 64 over 9. So here we multiply 4 by 9 and then we divide it by 9 in order to count factor with 64 over 9. 9 times 4 is 36, so in total in the numerator of this expression we will have 36 plus 64 divided by 9. 36 plus 64 is 100 divided by 9. Here we take a root out of this equation. Here am squared equals to 100 over 9. So we take a root from this equation, and finally we get that am equals to the square root of 100 over 9. So am equals to the square root of 100 is 10 over the square root of 9 is 3. So in conclusion, we found out that the length of the hypotenuse am is 10 over 3 units. Yeah. The length of this hypotenuse am is equal to 10 over 3 units in its length. In the next step, we will do another construction. That is to say, we will draw perpendicular on side BC in such a way that the perpendicular on BC will be also tangent to this circle. It is absolutely possible to do it because we have infinite points on side BC that we can draw the perpendicular. Out of the infinite points, we'll definitely find a point that it is simultaneously perpendicular to BC and also will be tangent to this circle. Okay. So this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We'll define the touching point of the perpendicular inside BC as T. We will define the point of tendency of the perpendicular with this circle as point K. In the next step, we will extend the perpendicular TK by straight line until it touches side AD, and we will define the touching point of the extended perpendicular TK on AD as point L. Okay. Actually, by doing this construction, we created here the middle right triangle MLT. In the middle right triangle MLT, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus theta. Okay. In the next step, we will define the center of this circle, this point as O. We will define the radius of this circle as X. We will define the point of tendency of tangent BT with this circle as H. We will define the point of tendency of tangent AB with this circle as S. We will join points O and H together by straight line. Point O is the center of the circle, point H is the point of the circle itself. Therefore, this is exactly the definition of a radius. Therefore, OH is the radius of this circle, and according to our definition, the radius of this circle equals to x. Therefore, OH equals to x. It is the radius of the circle. Here we can implement rule 1 with drawing. I'll repeat quickly on rule 1. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. We have here a circle and tangent AB that is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to point M. That is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees. We can implement rule 1 in our drawing. Why? Because in our drawing, we have also the radius OH that is drawn to point H, that is the point of tendency of tangent BT with this circle. And whenever you have a radius that is drawn to the point of tendency, that is actually point H, then tangent BT will be perpendicular to the radius HO. If BT is perpendicular to HO, it means that this angle equals to 90 degrees. And this angle also equals to 90 degrees according to rule 1. Likewise, we join points O and S together by a straight line. Line segment OS is the radius of this circle that is equal to x. Again, we have the radius OS that is drawn to point S. Therefore, according to rule 1, this angle equals to 90 degrees. And this angle will be also equal to 90 degrees. Likewise, we join points O and K together by a straight line. OK, line segment OK is the radius of this circle that is equal to x, according to our definition. Again, the radius OK is drawn to point K, therefore, according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Okay. In the next step, we will focus on the small quadrilateral OKHT. In this small quadrilateral, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the fourth angle. In total, they must be equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles of this quadrilateral to 360 degrees, the missing angle here must be equal to 90 degrees. So inside quadrilateral OKHT we have 4 right angles, therefore we can relate this quadrilateral must be at least a rectangle if not a square. So we will relate to this quadrilateral OKHT as a rectangle, and you know that the opposite sides of a rectangle are equal to each other. That is to say, side OK equals to the opposite side AHT in rectangle OHKT. But OH equals to X, therefore HT must be also equal to X. Likewise, according to the same rule, OH, side OH must be equal to side KT in rectangle OKHT. But OH is X, therefore KT must be also equal to X units in its length. So actually found out that quadrilateral OKHT is not a rectangle but a square. Why? Because all of its sides they are equal to each other. Likewise, we repeat on the same process on the small quadrilateral SOBH. In the small quadrilateral SOBH, we have 1, 2, 3 rectangles. Therefore, the fourth rectangle must be also equal to 90 degrees in its size. So inside quadrilateral SOBH, we have 4 rectangles. Therefore, we relate to this quadrilateral as a rectangle, and we know that the opposite sides of a rectangle are equal to each other. That is to say, side SO must be equal to the opposite side BH in rectangle SOBH. But SO equals to X, therefore BH must be also equal to X. Likewise, according to the same rule, side SB must be equal to the opposite side OH. But OH equals to X, therefore SB must be also equal to X. Again, we found out that quadrilateral SOBH is not a rectangle but a square. In conclusion, we found out that line segment BT in total it is equal to X plus X, that is 2X. So I write it down. Line segment BT equals to 2x units in its length. In the next step, we will prove that the middle right triangle LTM is similar to the small right triangle AMB or MBA. So I'll write it down. We prove that the middle right triangle LTM is similar to the small right triangle MBA. So why the middle triangle is similar to the small triangle MBA? First of all, those two angles they are both equal to 90 degrees, therefore they are equal to each other. So this is actually angle LTM. In the middle right triangle LTM, and it is equal to this angle, this is actually angle ABM. In the right small triangle MBA. Repeat again. Angle LTM in the middle triangle LTM equals to angle ABM in the small right triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. That is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself. So if we relate to angle theta as it belongs to the middle triangle LTM, it will be defined as angle LMT. And it equals to itself. So if we relate to angle theta as it belongs to the right small triangle MBA, it will be defined as angle AMB. Repeat again. This equation means that angle theta equals to itself. We just called to angle theta two different names. Angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles, they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually, this is angle MLT in the middle triangle LMT. And it equals to this angle, this is actually angle MAB in the small right triangle MBA. Repeat again. Angle MLT in the middle right triangle LTM equals to angle MAB, the small right triangle MBA. They're both equal to 90 degrees minus theta, therefore they're equal to each other. So actually proved that all the three angles in the big right triangle LTM are correspondingly equal all the three angles in the middle right triangle LTM are correspondingly equal to all the three angles of the right small triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. So I'm writing down the right middle triangle LTM is similar. Again, this is the sign of similar to the right small triangle MBA according to angle similarity rule. And from the fact that the middle right triangle LTM is similar to the right small triangle MBA, we will derive that the following relationship exists between their sides. We will derive that side LT in the middle right triangle LTM over side AB in the small right triangle MBA equals to side TM in the middle right triangle LTM over side BM in the small right triangle MBA, and it is also equals to side LM in the middle right triangle LTM over side AM in the small right triangle MBA. Repeat again. We derive that LT over AB equals to TM over BM equals to LM over AM. LT is the missing side, so we leave it as it is, over AB. AB equals to 2 units, therefore we'll substitute AB by 2. And it is equals to TM. What is the length of TM? From the drawing it is very easy to see that TM in total equals to x plus x, that is 2x, plus 8 over 3. So in total TM equals to 2x plus 8 over 3. So we'll substitute TM by 2x plus 8 over 3 divided by BM. Here BM equals to 8 over 3, so we'll substitute BM here by 8 over 3. And it is also equals to LM from the domain it is very easy to see that Lm in total equals to La plus Am. That is to say, Lm equals to La plus Am, that is 10 over 3. So in total, Lm equals to La plus 10 over 3. So here Lm equals to La plus 10 over 3 divided by Am. Am equals to 10 over 3. So we shall find out that LT over 2 equals to 2x plus 8 over 3 over 8 over 3, and it is also equals to LA plus 10 over 3 over 10 over 3. So in this long equation, those two sides they are equal to each other, therefore we create equation 1 from those two sides that are equal to each other. So according to equation 1, LT over 2 equals to 2x plus 8 over 3 over 8 over 3. Repeat again, according to equation 1, LT over 2 equals to 2x plus 8 over 3 over 8 over 3. So LT over 2 equals to, we have here in this side, on this side of the equation, 2x plus 8 over 3. So here we will multiply 2x by 3 and then we will divide it by 3 in order to overcome factor with 8 over 3. 2x times 3 is 6x. So in total, in the numerator of this expression, we will have 2x plus 8 divided by 3, and we have to divide it also by 8 over 3. So in this side of the equation, equation 1, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. After we cancelled 3, we left only with LT over 2, that is equals to 6x plus 8 over 8. So here we cross multiply this equation, equation 1, and we get that according to equation number 1, equation 1, 8 times LT equals to 2 times 6x plus 8. Here we divide this equation by 2, and we get that in this side of the equation we have 8 over 2 is 4, so in total in this side of the equation we have 4LT. That is equals to 2 over 2 is 1, so in this side of the equation we left only with 6x plus 8. Here we will divide this equation by 4, equation 1 by 4, and we get finally that LT, the length of line segment LT is actually 6x over 4 is 1.5x plus 8 over 4 is 2. So in total we actually found out that LT equals to 2 plus 1.5x. So I write it down in the original drawing that the length of line segment LT, this line segment LT equals to 2 plus 1.5x. We will continue to focus on the long equation. We have here in this long equation those two sides are equal to each other, therefore we will create equation 2 from those two sides that are equal to each other. So according to equation 2, we get that 2x plus 8 over 3 over 8 over 3 equals to LA plus 8 over 3 over 8 of LA plus 10 over 3 over 10 over 3. Repeat again, according to equation 2, we actually found out that 2x plus 8 over 3 over 8 over 3 equals to LA plus 10 over 3 over 10 over 3. So here we have, in this side of equation 2, we have 2x plus 8 over 3. Here we multiply 2x by 3 and then we will divide it by 3 in order to have a common factor with 8 over 3. So 2x times 3 is 6x. So in total, in the numerator of this expression, we will have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. And it is equals to, here we have LA plus 10 over 3. Here we multiply LA by 3 and then we divide it by 3 in order to have a common factor with 10 over 3. LA times 3 is 3LA. So in total, in the numerator of this expression, we will have 3LA plus 10 over 3, and we have to divide it also by 10 over 3. So in this side of equation 2, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. In the other side of the equation, we have also 3 in the numerator and 3 in the denominator, so 3 also will get cancelled. So what is left from equation 2 after we cancel 3 from both sides of the equation? What is left is actually in this side of the equation we left only with 6x plus 8 over 8. That is equals to, on the other side of the equation we left only with 3 times LA plus 10 over 10. In conclusion, found out that according to equation 2, 6x plus 8 over 8 equals to 3LA plus 10 over 10. Here we cross multiply this equation, equation 2. And we get that according to equation 2, 10 times 6x plus 8 equals to 8 times 3LA plus 10. Here we divide this equation 2 by 2. And finally we get that, according to equation 2, 10 over 2 is 5. Inside the brackets we have 6x plus 8. On the other side of the equation we have 8 over 2 is 4. Inside the brackets we have 3LA plus 10. So here we will open the brackets on both sides of this equation, equation 2, and we get that according to equation 2, 3 times 6x is 30x, plus 3 times 8 is 40, that equals to 4 times 3LA is 12LA, plus 4 times 10 is 40. So here we have 40 on both sides of the equation, so 40 will get cancelled, and we left only, in this equation 2, we left, in this side of the equation we have 30x, that is equals to, on the other side of the equation we have 12LA. We found out that according to equation 2, 30x equals to 12LA. Here we divide this equation by 12. And finally, we will get that according to equation 2, LA, the length of line segment LA, is equal actually to 30x over 12, that is actually 2.5x. the length of line segment LA is 2.5x. So you can write down in the original drawing that the length of this line segment LA is 2.5x. In the next step, I will copy this small quadrilateral ALBT in a new page with the circle that is inscribed inside it, and we will analyze this quadrilateral ALBT. So actually, this is quadrilateral ALBT with the circle that is inscribed inside it, that I copied from the original drawing. We'll define the point of tendency of tangent AL with this circle as K. We'll define the point of tendency of tangent LT with this circle as N. We'll define the point of tendency of tangent AB with this circle as M. And finally, we'll define the point of tendency of tangent BT with this circle as H. Here we can implement rule 2. I'll remind you quickly what is rule 2. We need for rule 2. The lengths of two tangents from a common external point to a circle are equal. We have a circle and we have here the common external point, point P. From the common external point, point P, we have two tangents to this circle, tangent PA and tangent PB. And according to this rule 2, the lengths of those two tangents are equal to each other. That is to say, the length of tangent PA equals to the length of tangent PB, or PA equals to PB. We can actually implement rule 2 in our drawing. Why? Because in our drawing, if we focus on the common external point, point A, from the common external point, point A, we have two tangents to this circle, tangent AK and tangent AM. And according to rule 2, they are equal to each other. That is to say, AK equals to AM. Again, in the common external point, point A, tangent AK equals to tangent AM according to rule 2. So if we define the length of tangent AK as A, then the length of tangent AM must be also equal to A because they are equal to each other. So you can go found out that AK equals to AM equals to A. In the next step, we will focus on the common standpoint, point B. On the common standpoint, point B, we have two tangents to this circle, tangent BN and tangent BH, and according to rule number 2, they are equal to each other. So BN equals to BH, and again on the common standpoint, point B, tangent BN equals to tangent BH in its length. So if we define the length of tangent BN as SB, if we define the length of tangent BM as B, then the length of tangent BH must be also equal to B because they are equal to each other. So if we found out that BN equals to BH equals to B, in the next step we will focus on the common standpoint, point T. From the common standpoint, point T, we have two tangents to the circle, tangent TN and tangent TH. And according to rule 2, they are equal to each other. That is to say, Tn equals to Th, according to the same rule, rule 2. So again, Tn equals to Th according to rule 2. So if we define the length of tangent Th as C, then the length of tangent Tn must be also equal to C because they are equal to each other. So in conclusion, we found out that Tn equals to Th equals to C. And finally, we will focus on the common standpoint, point L. From the common standpoint, point L, we have two tangents to this circle, tangent LK and tangent LN, and according to rule 2, they are equal to each other. That is to say, LK equals to Ln according to the same rule, rule 2. Repeat again, Lk equals to Ln according to rule 2. So if we define the length of tangent Lk as D, then the length of tangent Ln must be also equal to D because they are equal to each other. So we can find out that Lk equals to Ln equals to D. In the next step, we will add side AB to side LT in this quadrilateral ALBT. Again, AB plus LT. What is the value of side LB, side AB? Again, side AB plus side LT. From the drawing, it is very easy to see that AB equals to A plus B and LT equals to C plus D. So in total, AB plus LT equals to A plus B plus C plus D. likewise, we join side AL to the opposite side, side BT. So AL plus BT. AL plus BT. From the drawing, it is very easy to see that AL plus BT in total it will be equal to A plus B plus C plus D. Again, AL plus BT in total it will be equal to A plus B plus C plus D. So write it down. So those two expressions they are both equal to A plus B plus C plus D, therefore they are equal to each other. So we can write down that the expression AB plus LT equals to the expression AL plus BT because they are both equal to the same value, that is A plus B plus C plus D. In conclusion, found out that AB plus LT equals to AL plus BT. AB is 2, so we substitute AB by 2, and it is equals to plus LT. From the drawing, it is very easy to see that LT equals to 2 plus 1.5x. Okay, LT equals to 2 plus 1.5x. Therefore, we substitute LT here by 2 plus 1.5x, and it is also equals to AL plus BT. From the drawing, it is very easy to see that AL equals to 2.5x. Therefore, we substitute AL by 2.5x plus BT. BT equals to x plus x, that is 2x. So we substitute BT here by 2x. So in conclusion, found out that 2 plus 2 plus 1.5x equals to 2.5x plus 2x. 2 plus 2 is 4, so in total in this side of the equation we have 4 plus 1.5x. That is equals to 2.5x plus 2x is 4.5x. In conclusion, found out that 4 plus 1.5x equals to 4.5x. Here we'll subtract 1.5x from this equation, and finally we'll get that 4 equals to 4.5x minus 1.5x is 3x. So in conclusion, found out that 4 equals to 3x. Here we divide this equation by 3, and finally we will find out that x equals to 4 over 3 units in its length. Here the radius of this circle x equals to 4 over 3 units in its length. The radius, we just right now found out that the radius x equals to 4 over 3 units in its length. Again, our mission is to find out the area of this circle. The area of any circle is equals to pi times the radius of the circle squared. So the area of our circle will be equal to pi times the radius squared. The radius is x, therefore the radius squared is x squared. So the area of our circle is pi x squared. And we just right now found out that x equals to 4 over 3. If x equals to 4 over 3, it means that x squared equals to 4 over 3 squared. So it is pi times x squared, that is 4 over 3 squared. So it is pi times 4 over 3 squared. 4 over 3 squared is 4 squared, that is 16, over 3 squared, that is 9. So in conclusion, we found out that the area of our circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. And that is the answer to our question. I'm printing again. The area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, the area of this circle equals to 5.585 square units. The next step, I will summarize the lecture. In this lecture, we found out the area of this circle. In the drawing, we have quadrilateral ABCD. Inside this quadrilateral, we have the circle. In addition, we know that the length of side AB is 2 units, the length of side BC is 8 units, and side DC also equals to 8 units in its length. This is angle ABC, that is equal to 90 degrees, and this is angle PCB, that is also a right angle, it is equal to 90 degrees in its size. This is angle ABC, it is equal to 90 degrees in its size. So again, our mission is to find out the area of this circle. In order to find out the area of the circle, we did a construction. We actually extended side DA and side CB of this quadrilateral ABCD by straight line until they touch each other. This is their touching point. We define their touching point as point M. By doing this construction, we created the right big triangle, triangle DCM. We defined this angle as theta. So in the right big triangle DCM, this angle equals to theta. This angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles in any triangle. Then CB, line segment CB, is one side of quadrilateral ABCD, therefore it is absolutely a straight line. We extended the straight line CB by straight line, and the result is CM. When you extend the straight line by straight line, the result must be a straight line. Therefore, CM is a straight line. CM is one straight line. So, here we have the rule that the sum of the angles on one side of a straight line equals to 180 degrees. So if we focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the upper side of CM at point B? We have this angle that's equal to 90 degrees, to the right angle, plus the missing angle, angle ABM. In total, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So the missing angle must be equal to 90 degrees. In order to complete the sum of the angles at the upper side of CM it will be to 180 degrees, the missing angle must be equal to 90 degrees in its size. So if this angle equals to 90 degrees, it means that triangle ABM is a right triangle. So inside the right triangle ABM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Okay? Then we proved that the right big triangle DCM is similar to the right small triangle, triangle ABM. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we proved that all the three angles in the right triangle DCM, the right big triangle DCM, are correspondingly equal to all the three angles in the right small triangle NBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that side DC on the big right triangle DCM over side AB in the small right triangle MBA equals to side CM in the big right triangle DCM over side BM in the right small triangle MBA. Repeat again. We will derive that DC over AB equals to CM over BM. DC is 8, AB is 2, and it is equals to CM over BM. CM, what is the length of CM? From the domain it is very easy to see that CM equals to CB plus BM. That is to say, CM equals to CB, that is 8, plus BM, that is the missing side. So in total, CM equals to 8 plus BM. Here, CM equals to 8 plus BM over BM. So BM is the missing side, so we leave it as it is. So in conclusion, found out that 8 over 2 equals to 8 plus BM over BM. 8 over 2 is 4, so 4 equals to 8 plus BM over BM. Here we multiplied this equation by BM and found out that 4BM equals to 8 plus BM. Again, 4BM equals to 8 plus BM. Here we subtracted BM from this equation and we found out that 4BM minus BM is 3BM, so 3BM equals to 8. Here we divided this equation by 3 and finally found out that BM equals to 8 over 3 units in its length. Here, this side BM equals to 8 over 3 units in its length. Then we focused on the right small triangle MBA and we implemented the Pythagoras theorem on this small right triangle MBA. According to the Pythagoras theorem, in this right triangle MBM, AM squared equals to AB squared plus BM squared. Again, the small right triangle MBM, AM squared equals to AB squared plus BM squared. So AM squared, that is the square of the hypotenuse, equals to AB squared. AB is 2, therefore AB squared is 2 squared, that is 4, plus BM squared. Here, BM is 8 over 3, therefore BM squared is 8 over 3 squared, that is actually 64 over 9. So in conclusion, we found out that AM squared equals to 4 plus 64 over 9. So AM squared equals to, here, we have 4 plus 64 over 9. So we multiplied 4 by 9 and then we divided by 9 in order to have a common factor with 64 over 9. 9 times 4 is 36, so in total, in the numerator of this expression, we will have 36 plus 64 over 9. 36 plus 64 is 100 divided by 9. So in conclusion, we found out that AM squared equals to 100 over 9. Here we took a root out of this equation and finally found out that AM equals to the square root of 100 over 9. The square root of 100 over 9 is the square root of 9 is 10 and the square root of 9 is 3. So in conclusion, we found out that the hypotenuse AM equals to 10 over 3 units in its length. The hypotenuse AM equals to 10 over 3 units in its length. Then we did another construction, that is to say, we drew perpendicular on side BC in such a way that the perpendicular on BC will be also tangent to this circle. So this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. And we define the touching point of the perpendicular on BC as T. We define the point of tendency of the perpendicular with this circle as K. Then we extended the perpendicular TK by straight line until it touches side DA. We define the touching point of the extended perpendicular TK with side DA as L. By doing this construction, we added the middle right angle, triangle LTM. In the middle right angle LTM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Then we proved that the middle right triangle LTM is similar to the small right triangle MBA. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle that belongs to both triangles, so we can write down that angle theta equals to itself as a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we actually proved that all the three angles of the right middle triangle LTM are correspondingly equal to all the three angles of the right small triangle MBA. Therefore, those two right angles are similar to each other according to angle similarity rule. And from the fact that those two right angles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that LT over AB equals to TM over BM equals to LM over AM. LT is the missing side, so we leave it as it is, over AB. AB is 2, so substitute AB by 2. And it is also equals to TM. From the dominant, it's very easy to see that Tm in total equals to 2x plus 8 over 3. So substitute Tm by 2x plus 8 over 3 over Bm. Bm is 8 over 3, so substitute Bm by 8 over 3, and it is equals to Lm. Lm, from the dominant, it's very easy to see that Lm in total equals to La plus 10 over 3. So here, Lm equals to La plus 10 over 3 over Am. Am equals to 10 over 3. So in conclusion, found out that Lt over 2 equals to 2x plus 8 over 3 over 8 over 3, and it is also equals to La plus 10 over 3 over 10 over 3. Those two sides, they are equal to each other, therefore we created the equation 1 from those two sides, they are equal to each other. So here we have according to equation 1, Lt over 2 equals to 2x plus 8 over 3 over 8 over 3. So we have here 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to overcome the factor with 8 over 3. And we found out that 2x times 3 is 6x, so in total, in the numerator of this expression, we will have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. So in this side of the equation, we have 3 in the numerator and 3 in the denominator, so 3 we can cancel. After we cancel 3, we're left only with Lt over 2, that is equal to 6x plus 8 over 8. Here we must multiply this equation, we found out that 3 times Lt equals to 2 times 6x plus 8. Here we divided this equation by 2 and finally found out that 8 over 2 is 4, so in total on this side of the equation we have 4 Lt. That is equals to 2 over 2 is 1, so in total this side of the equation we left only with 6x over 8. So in total, according to equation number 1, we found out that 4 Lt equals to 6x plus 8. Here we divided this equation by 4 and finally found out that Lt equals to 6x over 4 is 1.5x and 8 over 4 is 2. So in total we found out that the length of line segment Lt is 1.5x plus 2, or Lt equals to 2 plus 1.5x. Here, this line segment Lt or side Lt equals to 2 plus 1.5x. Then we continue to focus on the long equation that we created. In this long equation, those two sides are equal to each other, therefore we created the equation 2 from those two sides that are equal to each other. So according to equation 2, we actually found out that according to equation 2, we actually found out that according to equation 2, we actually found out that 2x plus 8 over 3 over 8 over 3 equals to LA plus 10 over 3 over 10 over 3. So in this side of the equation we have 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to overcome a factor with 8 over 3. 2x times 3 is 6x, so in total in the numerator of this expression we will have 6x plus 8 divided by 3 and we have to divide it by 8 over 3. In this side of the equation we have LA plus 10 over 3. So here we multiply the LA by 3 and then we divide it by 3 in order to overcome a factor with 10 over 3. So LA times 3 is 3LA, so in total in the numerator of this expression we will have 3LA plus 10 divided by 3 and we have to divide it also by 10 over 3. So in this side of equation 2 we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. The other side of the equation we have 3 in the numerator and 3 in the denominator, so 3 also will get cancelled. So what is left from equation 2 after we cancel 3 from both sides of the equation? What is left is actually 6x plus 8 over 8 equals to 3LA plus 10 over 10. Here we cross multiply this equation 2 and found out that according to equation 2, 10 times 6x plus 8 equals to 8 times 3LA plus 10. Here we divided this equation by 2 and finally found out that 10 over 2 is 5, and inside the brackets we have 6x plus 8. In the other side of the equation we have 8 over 2 is 4, so and inside the brackets we have 3LA plus 10. Here we open the brackets on both sides of this equation 2, and found out that 5 times 6x is 30x, and 5 times 8 is 40. And it is equals to 4 times 3LA is 12LA, plus 4 times 10 is 40. So here we have 40 on both sides of the equation, so 40 will get cancelled and we left only with 30x, that is equals to 12LA. Here we divided this equation by 12 and finally found out that LA equals to 30x over 12, that is 2.5x. Here this line segment LA equals to 2.5x in its length. Then I copied the small quadrilateral ALBT with its circle that is inscribed inside it in a new page, and here I write this quadrilateral ALBT. This is the quadrilateral ALBT with the circle that is inscribed inside it. Here we can implement rule 2. According to rule 2, if we focus on the common standpoint point A, AM must be equal to AK according to rule 2. Again, AK must be equal to AM according to rule 2. So if we define the length of AM as A, then AK must be also equal to A. Again, so we found out that AK equals to AM equals to A. Then we focus on the common standpoint point B. From the common standpoint point B, we have two tangents to this circle, tangent BM and tangent BH. According to rule 2, they are equal to each other. That is to say, BM equals to BH. Again, BN equals to BH according to rule 2. Actually, it is BM that is equal to BH. BM that is equal to BH. BM equals to BH. Again, according to rule 2, BM equals to BH. So if we define the length of BM as B, then BH must be also equal to B because they are equal to each other. So if we found out that BM equals to BH equals to B according to rule 2, then we focus on the common standpoint point T. From the common standpoint point T, we have two tangents to this circle, tangent TH and tangent TN. And according to rule 2, they are equal to each other. That is to say, TN equals to TH. Again, according to rule 2, TN equals to TH. So if we define the length of Tn as C, then TH must be also equal to C because they are equal to each other. So we found out that Tn equals to TH equals to C. And finally, we focus on the common standpoint point L. From the common standpoint point L, we have two tangents to this circle, tangent LK and tangent LN. And according to rule 2, they are equal to each other. That is to say, LK equals to LN. Again, here, according to rule 2, Lk equals to Ln. So if we define the length of Lk as d, then Ln must be also equal to d because they are equal to each other. So if we're going to find out that Lk equals to Ln equals to d according to the same rule, rule 2. Then we added side AB to side LT. What is the value of AB plus LT? From the drawing it is very easy to see that AB equals to A plus B and LT equals to C plus D. So in total AB plus LT equals to A plus B plus C plus D. Again, AB plus LT in total equals to A plus B plus C plus D. Then we added side AL to the opposite side, side BT. What is the value of AL plus BT? From the drawing it is very easy to see that AL plus BT in total equals to A plus B plus C plus D. Again, AL plus BT in total equals to A plus B plus C plus D. So actually found out that AL plus BT also equals to A plus B plus C plus D. So those two expressions, they are both equals to A plus B plus C plus D, therefore they are equal to each other. That is to say, AB plus LT equals to AL plus BT. Because those two expressions are equal to each other. AB is 2 plus LT. What is the length of LT? From the drawing it is very easy to see that LT equals to 2 plus 1.5x. So we substitute LT by 2 plus 1.5x. And it is equals to AL plus BT. AL equals to 2.5x. Therefore, we substitute AL here by 2.5x plus BT. BT equals to x plus x, that is 2x. So BT equals to 2x. Therefore, we substitute BT here by 2x. So in conclusion, found out that 2 plus 1.5x equals to 0.5x plus 2x. 2 plus 2 is 4. So in total, in this side of the equation, we have 4x. We have 4 plus 1.5x. That is equals to 2.5x plus 2x. That is 4.5x. So in total, we found out that 4 plus 1.5x equals to 4.5x. Here we subtract 1.5x from this equation, and finally found out that 4 equals to 4.5x minus 1.5x is 3x. So in total we found out that 4 equals to 3x. Here we divided this equation by 3, and finally found out that x equals to 4 over 3 units in its length. Here the radius x of this circle equals to 4 over 3 units in its length. Our mission is to find out the area of this circle. Again, the radius x equals to 4 over 4 units in its length. Our mission is to find out the area of the circle. We know that the area of any circle equals to pi times the radius of the circle squared. So the area of our circle must be equal to pi times the radius squared. The radius is x, therefore the radius squared is x squared. So the area of our circle will be equal to pi x squared. X is 4 over 3. If x is 4 over 3, it means that x squared must be 4 over 3 squared. So in total, the area of our circle will be equal to pi times 4 over 3 squared. Pi times 4 over 3 squared equals to pi, and 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. So in conclusion, found out that the area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, the area of this circle equals to 5.585 square units. Okay, thank you very much.